Welcome back, everyone. My name is Susanna Smith, and I'm a doctoral student with California Intercontinental University. The topic of this PowerPoint presentation is going to be conducting a chi-square test of independence. We have a straightforward agenda for this PowerPoint presentation. First, we're going to have a brief overview of the chi-square test of independence. Then we're going to touch upon some common terms. We'll be performing 3 hypothesis tests on num-cars and num-defaults, like comfort in num-defaults, num-cars and like comfort. Then we'll conclude with major takeaways and questions and answers. At first glance, the chi-square test of independence can be rather intimidating. But with the PSPP tool, we have the ability to conduct an analysis in a very efficient manner. Our problem question with the chi-square test of independence is as follows. Do the values of one categorical variable depend on another categorical variable? Like any hypothesis test, it has a null and an alternative hypothesis. It has the notion the null hypothesis is expected to be true and there is no relationship between the variables. The level of significance is typically 0.05 or 5%. It uses contingency tables. Here are some common terms associated with the chi-square test of independence. Let's talk about categorical variables. Categorical variables are different than numerical values. First off, they rely on names or labels and can be examples such as gender, colors, and height. They are not numerical or quantitative in nature. The structure of the null hypothesis is as follows. There is no relationship between the first categorical variable and the second categorical variable. Subsequently, the opposing view would be the alternative hypothesis. There is a relationship between the first categorical variable and the second categorical variable. We would then establish the rejection rule to decide when we would reject the null. For example, in this instance, it would be P is less than alpha, where alpha equals 0.05. There is an additional step associated with the chi-square test of independence. We then have the post hoc rule. When the null is rejected, we would follow with the Cramer's V test. We have degrees of freedom, which is the number of independent observations in a sample minus the number of population parameters. The Cramer's V test helps determine how strong the relationship is between the variables if one exists. Let's talk a little bit about the degrees of freedom. It is basically the number of independent values that a statistical analysis can estimate. You can also think of it as the number of values that are free to vary as you estimate the parameters. The degree of freedom encompasses the notion that the amount of independent information you have limits the number of parameters that you can estimate. Typically, the degrees of freedom equal your sample size minus the number of parameters you need to calculate during an analysis. In most cases, it is a positive whole number. Now, the Cramer's V is very important, especially if you do determine there is a relationship between the variables. So the first analysis performed involved the sample num-cars and num-defaults. Using the PSPP tool, we determined no significant result was found. So let's break down how we came to this conclusion. First, we created the null hypothesis using the structure, which is there is no relationship between num-cars and num-defaults. Subsequently, the alternative hypothesis would then be structured as there is a relationship between num-cars and num-defaults. So let's break down our answer in the solution that we achieved. So running the PSPP test, we determined the degrees of freedom would be 6. The number of cases would be 150. The chi-square value itself would be 6.681. The p-value of the level of significance in this instant would be 0.351, resulting in the Cramer's v-test equaling 0.149. This value right here gives us the information that there is no relationship that emerged from when the test was performed. The second hypothesis test performed involved a sample light comfort in num defaults. Once again, this analysis using the PSPP tool revealed no significant result found. Once again, let's break down how we came to this conclusion. The null hypothesis would be converted to there is no relationship between light comfort and num defaults. The alternative would be there is a relationship between light comfort and num defaults. Now let's identify the solution again. The degrees of freedom would be 6. The cases identified is 150. The chi-square value is 6.681. The level of significance is 0.351. And the Cramer's v value is 0.149. You see this number here? Conducting the analysis once again revealed no relationship emerged. They are not correlated. The third and final test performed involved a sample, numCars, and light comfort. Unlike the other two tests performed, a significant result was found. So let's break down the hypothesis test and determine how we came to this conclusion. The null hypothesis in this instance is there is no relationship between numCars and light comfort. The opposing view is that there is a relationship between numCars and light comfort. The information and solution for this would be 9 degrees of freedom, 150 cases, chi-square value of 450. The p-value is 0.000 with a Cramer v value of 1.00. This indicates a perfectly symmetric relationship. This is very, very rare in this instance. So the Cramer's v test has some interpretations that need to be conducted. In the previous test performed, we got to see the v values. In those instances, they are numbers between 0.00 and 1.00. When the value of v is closer to 0, there is less strength associated between the variables. So in the first two tests, the v value was 0.149. This indicates there are no relationship between the variables. However, the third hypothesis test demonstrated there is a perfectly symmetric relationship. As I mentioned before, this is very, very rare, and it's not very common that the independent variable predicts the dependent variable. This is questionable and should involve some further investigation and analysis. There are some takeaways associated with the chi-square test of independence. I mentioned before that at first glance, the chi-square test can be rather intimidating. However, there are many computer programs out there that can calculate and perform the analysis in a very efficient manner. For this class, we have the opportunity to utilize the PSPP tool, which helped us calculate the information. It is very, very difficult to do the calculations by hand. The chi-square test of independence is used for testing relationships between categorical variables. Categorical variables are different than quantitative variables. They are things that are labels such as height and weight. So the test performed revealed 2 non-significant results and 1 perfectly symmetric result. The underlying principle focuses on probabilities. If A happened, what is the probability of B happening? Unlike the correlation coefficient between 2 quantitative variables, it does not in itself give an indication of the strength of the association. What does this mean? Well, if you want to know the strength, you have to proceed with conducting the Kramers V test. And you should always conduct a follow-up with the Kramers V test, especially if there is a relationship that emerged from the test. So, how do you conduct and calculate Kramers V values? First, it uses values from 0 to 1. Values closer to 0 indicate a weak association, or even no association at all. Values close to 1 indicate a strong association. Thank you all for watching this PowerPoint presentation, and I hope you enjoyed learning about the chi-square test of independence.